place that exists at the very fringes of our inhabited lands. A place rocked by the fists of Poseidon himself, where only a few feet of altitude separates the luscious forests from the driest deserts. That place is the Intertidal Zone. The Intertidal Zone is home to many strange and wonderful creatures, including those pictured here, the members of the Miller Lab. These particular organisms research animals on rocky shores all along the West Coast, and they've mastered the art of reading the invertebrate mind and body using space-age technology. Using innovative sensors to monitor real-time changes in bivalve heart rate in response to the environment, they can understand and describe how these sensitive animals handle the stress of climate change on an individual physiological basis, and how that stress may ripple through other aspects of intertidal life. Will these critters survive a changing climate here in the tidal zones of Point Loma, or in the estuaries of the Tijuana River? That remains to be seen. The Miller Lab holds the key to that knowledge in the form of silicon and wire. But beyond that block lie even more questions. Questions of heat, of predators, of competition. An endless series of variables for which the mad scientists of the Miller Lab will soon have a machine to decipher. For your consideration, San Diego Bay. A once fertile wetland oasis of teeming seagrass beds, dredged and polluted to near oblivion in the name of commerce and military prowess. Miles away in distant waters, the glistening shores of American Samoa. A vibrant and pristine collection of bustling reefs in jeopardy of collapse by the hand of a mere century of unchecked colonial trade and tourism. Two radically different ecosystems a world apart, facing the same perils of human negligence to nature. Now meet the OShell Lab, monitors of elemental change previously imperceptible to human consciousness. Roaming the bay with a PCO2 equilibration system and an eddy covariance platform, they probe familiar waters for changes in carbon on a daily, seasonal, and annual basis for signs of productive recovery. Measuring the breadths and size of a world plagued by pollution with a steadily rising fossil-fueled fever. Like any medical doctor, they understand the symptoms need untangling. That wind, turbidity, and the health of the reefs and grasses may all be interacting to affect the ocean's health. With the OShell Lab attending, the prognosis is encouraging. To the ecologist, a community is not a friendly neighborhood of like-minded souls bound by culture or local traditions, but a dogpile for survival. A never-ending tournament of different creatures fighting for finite space and sustenance. The focus is often placed upon interactions between species in the environment, to understand how they compete for resources in those common spaces. But the borders of these spaces are an arbitrary artifact of past understanding, and the connections between members of these embattled communities stretch far beyond the limits of any rectangular boundary, concrete or digital. Enter the Long Lab, a group of question-driven ecologists with a common thread throughout their work, understanding how ecosystems are connected and the role humans play in these connections. Their mission? To demystify how the changing of our climate and our societal footprint affects the creatures in the gray area between gill and lung, wet and dry, fish and fin and stomach foot. Wherever the sea touches the terrestrial realm, from the rocky shore to estuaries to the Coronado Islands, the Long Lab is on the case. We've arrived at Santa Catalina Island, 20 miles offshore from the metropolis of Southern California, where the Edwards Kelp Forest Ecology Lab takes a closer look at the diverse and diminutive communities lurking among the nooks and crannies of a mysterious ecosystem engineering algae called rhodoliths. The folds of these pink rock-like flora are home to a variety of fish and invertebrates, like the giant sheephead wrasse seen here, or the camera-shy flatfish right over here. Members of the Edwards Lab study how algae, fish, and invertebrates interact with one another in harmony, at least for now. But the ever-present specter of climate change threatens the overall biodiversity and ecological roles of these native species, with rising temperatures and acidification that will gradually wear and weaken the rhodolith to empty dust. Back in San Diego, our heroes from the Edwards Lab put the remedial powers of seaweed to the test. Enter a new generation of farmers. Those who till no fields, but still rear a bountiful harvest from the bosom of the sea, filtering pollution from San Diego Bay as they go. Meanwhile, far away in the bone-chilling waters of the Aleutian Islands off the western coast of Alaska, another gang of Edwards Lab members suction the kelp forest floor to get to the bottom of sea urchin settlement and the algae that blanket the benthos. If you take a tour through the dense, entangling tendrils of these mystical, swaying forests of Alaria, you'll seldom swim unaccompanied. Countless human societies have been built on the backs of schooling fish, through feed and through fortune. But as the forces of a changing climate threaten to crumble this Piscine foundation, humanity must rise to confront the reality of a rapidly approaching future, where these species are missing from the dinner table. Enter Nima Farshadi of the Lewison Lab, our champion for the pelagic rover. A model mathematician who skillfully weaves webs of satellite data into a reliable prediction of where tuna and sharks will move as the climate changes. On research vessels throughout the ocean, his colleagues deploy tiny spies that cling to the backs of his subjects. These spies report back to Nima about the fish's every movement, invaluable intel from the aquatic realm. He also has a global network of eyes on the ground. In every port, on every fishing boat, operatives record the number of shimmering beasts removed from the water each day. And from this data, Nima can divine their next move before it's made. An uncertain climatic future twists and turns through pelagic stocks like an unkempt gill net. But our data-driven fisheries fortune teller is here to guide our fishers and policymakers to sustainable success. Suspended 30 feet above the sand and 30 feet below the surface, off the coast of La Jolla hangs a curious fiberglass structure. Alien to this area in shape, form, and function, this otherworldly contraption has been readily colonized by fish, crabs, and a community of invertebrates large and small. The structure, aptly named an Ark, is a prototype of a powerful conservation tool, an aid to the restoration of damaged coral reefs, serving as a floral and faunal reservoir. The Ark allows researchers to reintroduce species that may have been previously damaged. Every 2 weeks, Jason Baer of Dr. Forrest Rower's lab descends to the structure on scuba to take measurements. The Ark is his brainchild, and while the iteration that hangs off of La Jolla is not suspended above a coral reef, it still provides valuable insight for future Arks. Currently, Jason is observing how his device interacts with currents, measuring water flow patterns both inside and outside the structure. He's also working to create self-sustaining grazer communities by providing shelters for urchins, which eat algae that may compete with coral growth. Over the next year, Jason, along with a team of researchers, will deploy Arks in Curaçao and Puerto Rico, saviors of reefs that face climate effects bound to last far beyond 40 days and 40 nights. In the rocky reefs and luscious kelp forests that caress the coasts of Southern California, the native spiny lobster and his compatriots aggregate in shelters, waiting to emerge under cloak of night. Through the darkness they wander, combing the forest floor for slow-moving creatures and the shards of biological flotsam and jetsam left behind by a world of marine carnage. Like generations of fishers before them, the salts of the OShell Lab have harnessed the lobster's affinity for Corpus detritus as a lure for trapping and collecting live individuals, with an aim to document the ebb and flow of populations through time and space. For the past 4 years, the lab, with substantial help from collaborators at the Universidad Autónoma de Baja California, has trapped a litany of lobsters throughout Baja and Southern California, collecting tissue samples and measurements of size and reproductive capacity for use in detailed fishery models. A vigilant set of eyes and minds, the OShell Lab stands watch over their scuttling flock, their presence a persevering force for stability among the lobsters and the communities they nourish, both man and beast. Picture, if you will, a microscopic worm in a macroscopic world. Subject to powers of nature beyond its comprehension, torn from muddy refuge into an unforgiving world, the Spyenid Worm is but a single grain of rice in the lunch of a California killifish. A square foot of mud can harbor 1,000 worms, a village of minuscule mud masons in a space the size of a bathroom tile. And while the mud tubes provide safety and shelter, a sense of security, the Spyenid Worm must reveal its position to feed, flailing feathery appendages into the water column to eke out its particulate livelihood. Such is the fascination of Dr. Brian Henschel. In collaboration with the Anderson Lab, Dr. Henschel delves into how water current speeds affect the fate of the many minute morsels that inhabit the marine marsh. To quote Shakespeare, "To live as a microscopic worm is a brutal existence, but to study the plight of a spyenid is a noble pursuit." Now feast your eyes upon the humble urchin barons. a desolate wasteland, the empty husk of a once towering kelp forest reduced to bare rubble and ruin, where the line between life and death is blurred. Ravenous hordes of zombified urchins creep across the ocean floor, scraping for every scrap of edible turf. These decrepit bottom feeders roam the barrens at will, empty vessels unwanted by predators they once feared. Here, their lone companion, Max Liebergezel of the Anderson Lab. Echinoderm necromancer and sheephead psychologist, day in and day out he studies the starving urchin's ability to persist, along with their predatory wrass's ability to distinguish the healthy urchin from the undead. He uses a series of macabre marionettes to measure the urchin's ability to cling to rocks as they cling to life. So far, it appears that as they loosen their grip on the mortal realm, they tighten their grip on the substrate, destined to roam a kelpless graveyard of their own making in the Subtidal Zone.
You can be sure that the mysteries of our oceans and their many inhabitants will never truly be solved. But you can be just as sure that the bright minds of San Diego State University's Coastal Marine Institute Lab and many others like it will never stop investigating in the Intertidal Zone. Now consider the grad student. Overpaid? Nope, that's not it. Definitely not.